Okay, today we're going to be looking at Chapter 10, Topic 11, Normal Distribution and the Empirical Rule. Okay, so there's three types, if there's a couple of different ways that data can be distributed, okay? There is skewed left. This would be where the median and mode are to the right of the mean, so it's skewed left. There's a normal distribution. The mean, the median, and the mode are all in the middle. Or they're skewed right, where the mean is to the right of the median and the mode. We are only going to be concerned with today data that is normally distributed, okay, so that it's even, okay, it looks like this middle one. Now, in order to talk about normal distribution, we have to talk about standard deviation, which is represented by the symbol, a sigma. The standard deviation is the typical distance of the data values from the mean. The mean is the average. The larger the standard deviation, the more spread out the data values are. Okay, typically this is used for normal distribution, which are bell-shaped curves. Normal distribution are symmetric. They're bell-shaped curves and they follow the empirical rule. The center of the data is the mean, or the average, okay? And it's represented with the symbol mu. That represents the mean. The sigma represents the standard deviation. Now, as long as we know the mu, the population mean, or the average, and the standard deviation, then we can construct a normal distribution curve. Now, the empirical rule tells you where the data lies, okay? Where most of the data lies. Approximately 68% of the data will be within one standard deviation from the mean, okay? So one above and one below. Approximately 95% of the data are going to be within two standard deviations of the mean. So two above and two below. And approximately 99.7% of all the data, so that's almost 100% of it, most of it, are within three standard deviations of the mean. This is three above and three below. This can help us tell or calculate, as long as the data is normally distributed, this can help us calculate where most of the data lies. Okay, so as long as we have the mean and the standard deviation, then we can construct a curve and we can recognize where most of the data is. So let me show you how we can construct a normal distribution curve. So this is what a normal distribution curve will look like. Okay, so right here, down the center, this is where the mean would be, okay, the average. The average is right in the middle. Most 68% of all the data is going to be within one standard deviation above and one standard deviation below the mean. "95% of the data will be within two standard deviations below and two standard deviations above the mean." So right in here, 95% of the data is in there. And then, three standard deviations from the mean, above and below, so right here and right here, 99.7% of the data is inside those two values, is between those two values. So almost all of the data. This is called the empirical rule. It's the 68, 95, 99.7 rule. It tells us how data is distributed. Okay, it tells us where the data lies if the data is normally distributed. This is another way of looking at it. Now, if 68% is between here and here, so we know that 68% is between here and here, that means that in this space, that's 34%, and in this space, that's also 34%. Now, if we know that, Now, if we know that between these two standard deviations, 2 above and 2 below, there's 95% of the data, and we already have 68, 95 minus 68, then that means that in this little piece between 1 and 2, 13.5% of the data is there, and for this one, 13.5% of the data is there as well between 1 and 2. Now, if we know that 99.7 is between these two, and we already have 95% of the data, then that means that in here, in this little area, is 2.35% of the data, and right here in this little area is 2.35% of the data as well. And then in this one, 0.15%, and in this little tiny area, 0.15%. So this is how each piece is split up. So you can, if you look at each piece, you can see you can see exactly how much of the data is in that little piece. Here we go. So this is how all the data is split up into the little pieces. Okay, 34 here, 34 here. It's completely symmetrical. So 13.5 here, 13.5 here, 2.35, 2.35, and 0.15 on this side of the 3 standard deviations and 0.15 on this side. Okay, the total percentage under the curve here is 100%. Okay, let's see if we can use this to answer some questions about probability of normal distribution. So the distribution of weights of all boxes of Raisin Bran of cereal is approximately normal. Okay, so it's normally distributed. The mean is 20 ounces. The standard deviation is 2 ounces. This is all we need to calculate the curve. Okay, so let me draw the normal distribution curve. Not the best. Let me try that again. Okay, that's a little bit better. Okay, so this will be the mean. This will be 1 standard deviation above. This will be 2 standard deviations above, and this will be 3. This will be 1 standard deviation below. This will be 2 standard deviations below, and this will be 3. Okay, so the mean is right here. Okay, so this is 20. Well, let me put it underneath actually. So this is 20. This is 1 standard deviation above. The standard deviation is 2, so that's 22. This is 2 above, so this is 24. And this is 3 above, so this is 26. This one is 1 below, so it's 18. This one's 2 below, so this is 16. And this one's 3 standard deviations below, so that's 14. Okay, now we know that 34% is in here and here. 13.5% is here and here. 2.35% is here and here. and 0.15% is in here, and 0.15% is in here. Okay, so with this information we can answer any of these questions. So we want to know the probability that the weight is less than 16 ounces. So the probability less than 16. Okay, so let's look at our curve. So we're looking for the probability of it being less than 16. Okay, so we just need to look at the curve where it's less than 16. Okay, all the probabilities where it's less than 16. So that would be, so here's 16. We want the probabilities to the left of that, so there's two of them. 2.35 and 0.15. 2.35% plus 0.15%. So that would be 2.5, I believe. 2.5%. So expressing that as a probability, the probability is less than 16 is 0.025. Because that's 2.5%. So this is the first one. Okay, so let's see what number 2 is asking us. Number 2, we want the probability that the weight is greater than 18 ounces. Okay, so probability that the weight is greater than 18. Okay, so we just need to look at our chart and add up the probabilities that are to the right of 18. Okay, so that would be this one, this one, this one, this one, and this one. So you need to add all of these together. Okay, that's 34% plus 34% plus 13.5 plus 2.35 plus 0.15. 34 plus 34 plus 13 plus 2.35 plus 0.15. So that's 83.5%. And if we express that as a probability, that's 0.835. The probability of the weight being greater than 18 is 0.835. Okay, let's look at number 3. Less than 24. Okay, so we want the probability that the weight is less than 24. So we'll be looking at all of the probabilities to the left of 24. Okay, so that would be this one, this one, this one, this one, this one, this one. So we got, so we got this one, which is so we have 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15. Let me just add those together. 13.5 plus 34 plus 34 plus 13.5 plus 2.35 plus 0.15, and we get 97.5%. Okay, turning that into a probability, 0.975. So that's the probability that the box of cereal has less than 24 ounces in it. So pretty likely that it's going to have less than 24 ounces in it. And then number 4, between 14 and 26. I guess I should have been using a variable here. So the probability that the weight is between 14 and 26. So between 14 and 26, so that would be the probabilities between here, and here. This one, this one, this one, this one, this one, and this one. However, that's 3 standard deviations below, 3 standard deviations above. I actually already know the percentage because of the empirical rule. It's 99.7%. Turning that into a probability, 0.997. So the probability that the weight is between 14 and 26 is 0.997.